Welcome to our deep dive into Elastic GPU Service or EGS. Imagine if you have a team of data scientists who are all just clamoring for GPU time. It's like a constant battle for resources, right? That's the problem that EGS is tackling head on, and today we are going to explore how it all works. EGS is the only solution out there that is applying AI and intelligence to solving this battle for GPU resources. So, what is EGS? EGS is the most scalable and efficient GPU utilization platform that transforms your AI ML workflows. So, what's really interesting here is that EGS promises not only to make life easier for data scientists, but also to save a good chunk of money in the process. Let's look at the problem a little more closely. You've got these powerful GPUs sitting there, but they're not always being used efficiently. This visual illustrates the problem really well: static versus dynamic allocation of GPUs. In the static model, which you're seeing here, you've got these GPUs assigned to different tasks or jobs or teams. That is, say you have 100 AI models. So 100 GPUs are assigned to them, one GPU for every AI model. So when GPUs are not being used, like you see here, there are gaps. So how does EGS step in to solve this? Well, EGS acts as this intelligent resource manager. It dynamically allocates GPUs to jobs as they come in, so you don't have GPUs just sitting idle, waiting around. So instead of having these dedicated GPUs for specific models or teams or tasks, EGS creates this pool of resources that can be shared and allocated on demand. Now dive into some real-world scenarios. This scenario involves two teams: a production team that handles all those incoming inference requests, and a development team that's busy testing and experimenting. In a traditional setup without EGS, each team will have their own dedicated GPUs, which will lead to a lot of wasted resources. The production team here has 100 AI models ready to go, but at any given time, they're only actively using like up to 30 of them based on usage patterns. So they've got all these GPUs just sitting there idle most of the time. The dev team has 50 models, but because of budget constraints, they can only run up to about 20 at a time. So they've got a smaller pool of GPUs to work with. So first up, let's see what this looks like in the EGS UI. We see those numbers once again: a total of 120 GPUs that are allocated. 50 of those are utilized at this time. The production team is using 30 GPUs for 30 of their AI workloads, and the dev team is using 20 GPUs for their test jobs that are running. So we see a wastage of 70 GPUs, or 60% of the GPU resources are wasted. Then there's some more information here that of those 50 workloads, what type of workloads they are. And there's a neat little heat map here which shows the utilization of each of those 50 GPUs in use. So when you hover over each GPU, you get specific details on each utilization. For example, this GPU is 98% utilized. Now let's see what the cost dashboard looks like. So the cost dashboard shows $24,000 of allocated GPU costs, but only $10,000 of GPU resources being used by both teams. So a wastage of $40,000. But now let's see what happens when we flip the switch and enable EGS. So both teams will essentially share resources and let EGS handle the allocations. The production team still needs to make sure that they handle those 30 concurrent AI models, so EGS reserves 30 GPUs specifically for them. But what about the dev team? The dev team needs at least 5 GPUs available at all times to ensure that they can keep their critical tasks running. So that leaves a pool of 35 GPUs that EGS can dynamically share between the two teams as needed. So we don't need 120 GPUs allocated as we saw in the static model. That's a whopping 70% less GPU resources allocated right off the bat. So with so few allocations, how does EGS handle those fluctuations in demand? Let's explore that. At time t0, at this point in time, the production team is running 25 models and the development team is running 10. Okay, so they both are well within their allocated limits. What does the EGS dashboard show for this scenario? It shows that only 35 GPUs are allocated in total, 25 for production and 10 for dev. And here's where it gets really interesting. Even though both teams have access to a larger pool of GPUs, EGS is only allocating what's needed at that specific moment. So it's not blindly allocating these resources, it's actually analyzing the demand and adjusting accordingly. And the GPU wastage on the dashboard highlights this beautifully. Every single allocated GPU is actively running a workload. So even with those fluctuating workloads, EGS is managing to squeeze out all that inefficiency. That translates directly to cost savings as well. This cost analysis view shows that the total GPU cost for this period is significantly lower than it was with the static allocation model. Every dollar spent on GPUs is actually contributing to running these AI workloads. Now let's see what happens when there's a surge in demand. The production work jumps from 25 to 30 models, and the dev workload drops to 5. Okay, so now we have a situation where one team needs more resources while another team needs less. EGS responds seamlessly. The dynamic allocation dashboard for time T1 is now showing that EGS has automatically adjusted the allocation. The production team now has 30 GPUs, while the dev team has 5. But here's the key point. The total number of allocated GPUs remains at 35, and there is still zero wastage. So EGS is like a master juggler, effortlessly keeping all those GPUs in the air and making sure no one drops the ball. Here's something interesting too. The job priorities leaderboard on this dashboard shows that it takes job priorities into account while making the allocation decisions. So those high priority production jobs are always going to get the resources they need. You don't want a critical production job getting stalled because a low priority development task is hogging up a GPU. Now let's fast forward to time T2. In this scenario, the production traffic has calmed down and they're only running 5 models. But at the same time, the development team is now able to run all 20 of their models. So it's like the perfect opportunity for EGS to shift those unused resources from production over to development. The dynamic allocation dashboard for T2 now shows that the production team's allocation has been reduced to 5 GPUs, while the dev team now has 20. Even though the dev team is now running more workloads, the total GPU cost remains relatively low. So we are seeing improved utilization, reduced costs, and enhanced operational efficiencies. It's clear that EGS can be a real game changer for organizations running AI workloads. Let's shift gears and explore how EGS empowers data scientists to work more effectively. One of the key features is the EGS SDK/API/notebook. So instead of having to manually request and manage GPU resources, data scientists can use code to do it. This is a snippet of Python code that demonstrates this. So a data scientist who's comfortable with Python can just write a few lines of code and boom, they've got the GPU resources they need. And what's really neat is that the code itself is very straightforward and easy to understand. It's all about making things simpler and more efficient for data scientists. Okay, how do things work behind the scenes with dynamic allocations? There are views within the EGS UI that show workspaces, GPU requests, and priority queues, and details on AI workloads. Here, in the GPU request section, admins can see all pending GPU requests from different users and workspaces. It's like a central hub for managing all those GPU requests. And the cool thing is that admins can prioritize those requests based on different criteria. Now to the workspaces. EGS allows admins to create these personalized workspaces for individual users or teams. So each user or each data scientist has their own little sandbox within EGS where they can work on their own projects. And within that workspace, users have access to all the information they need to manage their workloads. Here, in the admin view of all the workloads that are running, you can see that the system has fetched all the model hyperparameters related to the workload. As you see, it's not just about allocating those GPUs based on job priority. It's also about giving data scientists the tools they need to monitor their work and make informed decisions. From a security perspective too, these workspaces play a very important role. There's RBAC for each workspace that ensures that a data scientist can only see and access the resources within their assigned workspace. They can see what's running, track resource usage, and even look at historical data. So we've covered a lot of ground with EGS today. We've talked about challenges of GPU utilization, the benefits of EGS, how it dynamically allocates resources, and even how it integrates with the data scientist's work. Please also go to www.avacia.io to learn more about EGS and our other products.